Namaskar students and welcome. In this video, we are going to see the question answers of 8th Science lesson number 14 Measurement and Effects of Heat. This is going to be part 1 of the question answers children. Question 1a. Whom should I pair with? This is group A and I have written the answers directly in group B children. Temperature of a healthy human body, it is 98.6 degrees Fahrenheit. Boiling point of water, 212 degree Fahrenheit. Room temperature, 296 Kelvin. Freezing point of water is 0 degree Celsius. Question 1b. Who is telling the truth? A. The temperature of a substance is measured in joules. It's false, children. The temperature of a substance is measured in degree Celsius or degree Fahrenheit or Kelvin. Joule is the SI unit of measuring heat energy, children. B. Heat flows from an object at higher temperature to an object at lower temperature. It's true, children. C. Joule is the unit of heat. It's true. Just now we saw in first one, children. Joule is the SI unit of measuring heat. D. Objects contract on heating. It's false. Objects generally expand on heating. They don't contract, children. E. Atoms of a solid are free. False. Atoms of a solid are bound to each other due to the forces acting between them. They are closely packed with each other, children. So they are not free. F. The average kinetic energy of atoms in a hot object is less than the average kinetic energy of atoms in a cold object. It is false, children. The average kinetic energy of atoms in a hot object is more than the average kinetic energy of atoms in cold object. Of course, children, in hot objects, the atoms will have more energy because they are taking the heat energy. Question 1c, you will find if you search. A thermometer is used to measure temperature. The apparatus used to measure heat is called calorimeter. Temperature is the measure of the dash kinetic energy of the atoms in a substance. It is the average kinetic energy which we are measuring when we are seeing the temperature. The heat contained in the substance is the measure of the dash kinetic energy of atoms in the substance. When we see the overall heat energy, we see the total kinetic energy. When we measure temperature, we see the average kinetic energy of atoms. Question 2. Nishigandha kept a vessel containing all the ingredients for making tea in a solar cooker. Shivani kept a similar vessel on a stove. Whose tea will be ready first and why? Shivani's tea will be ready first. Of course, children, because Shivani is keeping it on the stove. Because the amount of heat energy received by the vessel on a stove will be far greater than the heat received by the vessel kept in a solar cooker. Why is this so, children? This is because the fuel used in stove is already a converted form of indirect solar energy in its concentrated form. The fuel is formed with the help of solar energy only. So it is the concentrated form. It is the converted form. So it is having more power. That is why the tea will be ready first on the stove. Question 3. Write brief answers. Describe a clinical thermometer. How does it differ from the thermometer used in laboratory? We will write it in the distinguish between form, children. This is clinical thermometer. This is laboratory thermometer. A clinical thermometer has a range of 35 degrees Celsius to 42 degrees Celsius and is more sensitive to temperature. Clinical thermometer is generally more sensitive, children. A laboratory thermometer has a range of minus 10 degrees Celsius to 110 degrees Celsius and is not sensitive to temperature. It is not sensitive, children. It will immediately change its temperature. This narrow range is suitable for measuring temperature of humans and animals. This wide range is suitable for measuring in laboratories for scientific purposes. This is a wide range, children. -10 to 110. It is a huge range. But this is just 35 to 42 degrees, children. Very small range. The kink or bent constriction does not allow the reading to fall down immediately, and so we can take some time for reading temperature. There is no kink and immediate reading must be taken while the thermometer is inside the setup because the mercury falls down. Here, children, there is no kink in the laboratory thermometer. So if you want to see the reading, you have to see it immediately and only when the thermometer is inside the setup. Thus, clinical thermometers are different from laboratory thermometers. Now we use digital thermometers as clinical thermometers because mercury is poisonous. Nowadays we are not using mercury thermometers at home, children. We are using digital thermometers. Next question. What is the difference between heat and temperature? What are their units? This is heat, this is temperature. It refers to the amount of heat present in the body and is denoted by Q. The amount of heat present inside any object is called as the heat. It is shown by Q. It is the measure of heat's intensity and is denoted by T. How hot or how cold the object is. What is the intensity of the heat present in the object? That is called as the temperature. If the temperature is 40, heat intensity is less. If the temperature is 100, heat intensity is more. So that is the temperature denoted by T. It is measured in joules. It is measured in degrees Celsius, Fahrenheit and Kelvin. So joule is the unit of measuring heat and the unit of measuring temperature are degrees Celsius, Fahrenheit and Kelvin. Calorimeter is used to measure heat energy. Thermometer is used to measure the degree of hotness or coldness of object. So calorimeter is used to measure heat and thermometer is used to measure temperature. Heat flows from a hotter object to a cooler object. It rises when we heat it and falls when we cool it. The temperature. It rises when we heat and falls down when we cool it. It is not getting transferred from one object to other. Next one. Explain the construction of a calorimeter. Draw the necessary figure. Calorimeter is a device used for measuring heat. Its construction is as follows. It consists of a metallic vessel and stirrers. There is one stirrer. We can have more than one stirrer. They are made of copper or aluminium. Generally, we are using copper, children, but sometimes we use aluminium also. The vessel is then kept inside a wooden jacket that contains heat insulating materials. This is the vessel which is made of wood, children. Inside this wooden box, we are keeping this metallic vessel. The outer wooden jacket acts as a heat shield and reduces the heat loss from the inner vessel. So the outside wooden box is not allowing the heat energy to go out. The outer jacket has an opening through which a mercury thermometer is inserted into the calorimeter. There is one opening through which we are putting the thermometer for checking the temperature. So this is the basic setup of a calorimeter, children. It is containing a metallic vessel which is kept inside the wooden box. Explain why rails have gaps at specific distances. All solids expand on heating. As rails are made up of steel, they also expand in summers and contract in winters because the rails are also made from metal, which is steel. This expansion can cause sagging and contraction can cause bending of rails, which could be dangerous for the railway. Thus, the railways may get derailed and the passengers may die due to accident, and so gaps are provided in railway tracks to avoid this dangerous situation. If the railway tracks are expanding or contracting, if their shape is changing because of this, then the railways will not be able to walk properly on the rails, on the tracks. So this can become a dangerous situation. These gaps get closer in summer and wider in winter. Next one, explain with the help of formulae the expansion coefficient of liquid and gas. A liquid does not have a definite shape, but it has a definite volume. A gas does not even have a fixed volume. Therefore, the expansion of a gas is measured by keeping its pressure constant. Liquid is at least having a definite volume, children, if it doesn't have a definite shape. But gas doesn't have a definite shape and it doesn't have a definite volume also. So we are considering, we are keeping a fixed pressure and then we are checking the expansion coefficient. This volumetric expansion coefficient or the constant pressure expansion coefficient formula is the same for both liquids and gases and is as follows. The formula is same for both, children. V2 is equal to V1 1 plus beta delta T. Here delta T is the change in temperature. V1 and V2 are the initial and final volumes of the liquid or gas at constant pressure. Beta is the volumetric expansion coefficient of liquid or constant pressure expansion coefficient of gas. So this is the formula, children, for the expansion coefficient of liquid and gas. Now the word problems, children. Solve the following examples. First one, what must be the temperature in Fahrenheit so that it will be twice its value in Celsius? We have this formula given in our textbook, children. F minus 32 upon 9 is equal to C upon 5. They are asking what should be the temperature in Fahrenheit so that it will be twice the value in Celsius. Whatever is the value of Celsius, Fahrenheit value will be double of that. So F will be equal to 2C. So in place of F here, we will write 2C. 2C minus 32 upon 9 is equal to C upon 5. Only in place of F we have written 2C, children, and now we will cross multiply. 5 bracket 2C minus 32 is equal to 9C. 9 into C is 9C. 5 2s are 10. 10C. 5 should be multiplied with both, children. 10C minus 160. 5 into 32 is 160. Remember, children, we have multiplied 5 with this one also and with this one also. With both we have multiplied. Now we will shift this 9C to this side and we'll shift 160 to other side. Now see what we have done, children. Whenever we are shifting the alphabets and numbers, their sign will become opposite. So 9C was positive. It went to this side. It became negative. 10C minus 9C. 160 was negative and it went to other side and it became positive. So 10C minus 9C is equal to 160. 10 minus 9 is 1. So C is equal to 160. So when C is 160, F is double of that, Fahrenheit. So 2 into 160, 320. Therefore, the temperature in Fahrenheit must be 320 degree Fahrenheit. So here we complete with the question answers of this lesson. We will continue the remaining word problems in the next video. Thank you for watching till the end.